Hi, today we're going to go through a couple of examples of Markov chains. The first is going to be a linear dynamical system, and the second is going to be an example of Q-learning. So I'm going to have to rip through it as well because I haven't got much time here, but the first example is going to be a linear dynamical system with 4 states. So we've got students who may or may not be interested in studying a coding course, and they're all sitting here in this potential students pool. Now these potential students have 2 things that they can possibly do, 2 actions. Their actions are with a 90% probability remain being a potential student, or with a 10% probability move to study the course that we're offering. Now once they get there to that course, there's 4 things that can happen. They can either stay studying for a 65% chance, they can either drop the course completely and never come back to being a student, so they leave, the 7% chance. They complete the course, there's 20% of those that do, and with an 8% chance they'll go back and defer their course and go back into the pool of students that may come back later. So 4 states, and we've got a bunch of different probabilities that they may move from states to other states, and once they reach these 2 states they don't move back. So this is how we code that, this is how we represent it. So there's a time period here, we've got 100 time periods that we're going to run this for, and we've got a matrix where the columns are the states and the rows are the actions and the probability of those actions happening. So this first column is the P state, and the probability of staying in the P state is 90%. Probability of moving to the S state is 10%. The probability moving from that state to one of these 2 is 0 and 0, so that's C and D. And you can see the same in these, and then this one, once you get to C you're going to stay there, and D you're going to stay there. So we implement that, and then we plot that and have a look at over the 100 time periods what happens. So everyone starts, 100% of our students start in the potential students, and each period more and more of them move from that potential period students into the studying. Those same students from that studying go one of 4 ways. They either go into the completed courses and the drop forever, until finally 100% of our students have either dropped the course or completed the course and they've left the model. What you can see, interestingly enough, is that the dropped forever is about 25% and the completed the course is about 75%, which is exactly the same ratio between the 2 probabilities that we can see up here, 20% and 7%. So in the end, that is the only sort of probability that mattered, because everyone came through there and popped out the other end. Alright, Q-learning. Q-learning is a bit deeper, but I'll just talk about what we've offered here. So if we're talking about students interested in a course again, this time we want to see if we can influence the state or the level that this student's interest is in the course by offering scholarships. So let's say that we've got students with level of interest of between 1 to 10, and at each point they have a 50% chance, this is our P0 value, there's a 50% chance of their interest going up or down. So that's one way or the other, flip or a coin. But if we go in and offer a scholarship, then it's going to be more interesting to do it. The level of interest could go up, and it's a 75% chance that it'll go up. So this is our second state. So these are our 2 particular states, one for no scholarship, one for a scholarship. And we've got our 10 levels. So what we want to do is figure out for each level, what is it worth offering this particular scholarship if there's a given cost. So at each cost, is it the right thing to do to offer that scholarship? And we can have a cost of nothing, so it can cost us nothing, it's all done by donations, I guess, or all the way up to 2.0, which is just a value that we've chosen. So we've implemented a couple of functions here to run through and find what happens to each of those it's unguided learning, this, so it goes through and says, if I give you this option, tell me what's going to happen. And we're going to do that down here, we're going to do that 1,000 times, and then we're going to graph it red and blue. So, and it gives us basically another matrix. So this is a matrix with 1 to 10 for the enthusiasm level, and it gives us the cost of offering the scholarship. And after running it for 1,000 times, we can see reds mean offer the scholarship, blues mean don't offer the scholarship. So if your scholarship is free, then do it no matter what the level of enthusiasm. You're going to get some benefit. If it costs you 0.1 at levels of enthusiasm 3 and 4, you don't want to offer it. But at any other level, you do. And you can see as it gets more and more expensive, there's more and more blue. So that tells us that we shouldn't be offering the scholarship at those levels. Interestingly enough, the more time you give to the scholarship to get through, so here we're running it at 10,000 times, the more red you get. So the more likely it is that you would offer that scholarship. All the way down here, we've got 10 to the 7, and we've basically got all red except for level 10 or level 1 of enthusiasm. And that's all the time I've got to do this, so I hope you enjoyed that and you got a little bit out of Markov chains. Thank you.